Nomenclature continued. We're going to talk about something called stereocenters now. Stereocenters. Need something fancy for that. How about this one? Not fancy enough. How about a shadow? There we go. So, name the following. Well, we got our old nemesis here, the parentheses. This 2 means 2 methyls, both attached to this. This 2 means 2 of these groups, both attached here. CH2 once, twice, 3 times, C with a V. And over here, not so hard. Take this 2 off, stick a C up there. That's an isopropyl group up there. Longest chain, bottom right or far right, will both get you the longest chain. We'll go with orange. 1. There's a methyl on 2. That's why I chose to go this direction. 3, 4, 5, 6. That's tricky. 7, 8, 9, 10, 11, or 7, 8, 9, 10, 11. But if you go 7, 8, 9, 10, 11 down here, then you've got to name this whole thing as a group. You want to try that? No, I didn't either. Sometimes you got to use that as your decision making. That's harder that way. I mean, it's not undoable. So I'm just going to go 7, 8, 9, 10, 11. How do you say 11 carbon? Yeah. Undecane. Don't even know where to put it. I'll put it here. Undecane. And what's that group on carbon 2? A methyl. What's that group on carbon 6? It's an iso. Do you know how I know? I see the V. Yeah. How many carbons in it? 6? 1, 2, 3, 4, 5, 6. Isohexyl. Iso H. Iso H. Versus isopropyl. Iso P. They both go by I. They both go by ISO. But after the ISO, you got a P for propyl and a H for hexyl. So that's first. Isohexyl first. 6 isohexyl. Way over here. 6 isohexyl. 8. What's the iso on 8 called? It's got 3 carbons. 1, 2, 3. Isopropyl. What's that group on 2 called? 2-methyl. We haven't even got to the big word at the top of the screen. In front of that, there's going to be either an R or an S for the stereocenter. Stereo. Why is it called a stereo at home? Because you got 2 ears and you got a right speaker and a left speaker. Yeah, right headphones, left headphones. Stereo. Is your right ear and your left ear the same thing? No, they're different, right? You would look odd with your right ear on your left, where your left ear should be, right? Same for your hand. It would look odd. I mean, you could still make life work, but it would be a different life. You agree, right? So yeah, spatial orientation is very important. And stereocenters is similar story. Now to do stereocenters, you got to have 4 different substituents. That's a fancy way of saying groups on the same atom. I'm going to make your life a little easier. In our course, we're only going to talk about carbon stereocenters, but I want you to know that there are other atoms that can be stereocenters. Okay? There are many other atoms that can be stereocenters. But carbon's the most popular one, so we're going to stick just with that. Okay. So I do see that carbon that has the wedge and the dash, and I will list the 4 groups on there. A hydrogen's a group, it's an atom. Isopropyl is a different group, right? If you had to call this a group on the left, I'd say it's a propyl group, right? 3 carbon. And the one to the right is just a monster group. Let's just call it that. It's different than the other 3 for sure, right? You've identified there's 4 different groups. You know there's a stereocenter on carbon number 8. Yeah. And it's going to be either R or S based on the system that was developed by Kahn, Ingold, and Prelog in the 20s. The other century 20s people. Okay. All right. So, yeah. Just realized that's been around for 100 years now. Okay. Now the system goes like this, and there's lots of videos on this. But you got to assign numbers 1, 2, 3, 4 for the 4 different substituents on your stereocenter. And the criteria is based on the mass of the atom attached to the stereocenter. Okay, so I've got my number 4 group figured out, and that's it. The lightest atom attached to the stereocenter is what? H. That is the number 4 group in this example. And I like circling those numbers so you're not confused that they're not chain numbers for sure, right? I'm going to have 1, 2, 3, 4 in circled numbers. And the other 3 things are all carbons. We call that a tie. You go 1 atom at a time, people. That's the system. Don't try to say, oh, that's a bigger thing over there. It's going to win. That will get you like half the time. So I'm going to highlight the 3 atoms that are tied. Carbon ties, that's a little big. Where's my, there we go. Come on, everybody, there we go. Carbon ties carbon, ties carbon. Now, what's the heaviest thing on each of those carbons? People, you have to keep going away from the stereocenter when you're answering these questions. So in each of the 3 highlighted carbons, they each have 1 more bond to carbon going away from the stereocenter, at least, right? So that's another tie in another color. But we're going to keep doubling back until we've broken the tie. So the heaviest thing on this one is another carbon. And the heaviest thing on this one is another carbon. And the heaviest thing on this one is another carbon.
Well, you could say it for all of them.
I can so far, yes. Now go back to the pink highlighted carbon. What is the heaviest thing that's not been highlighted attached to each of those? And we have a winner right here. That I'm gonna put a check mark on the things that tied. Check. That's supposed to be a check. 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 Go back to pink.
Oh,
Now put a highlighter on the next heaviest atom. In this case, I'm going to have to squiggle out the 2 H's and put them on.
Oh, is it because the other ones have hydrogen attached?
Yeah, it's only hydrogen. Where's my purple highlighter? Is what I want. Purple highlighter, purple highlighter. I'm comparing this hydrogen to that second carbon. Which one's heavier of these 2? The C.
Yeah.
So that's a winner, and a loser. That sounds so harsh, I know. And then I'm going to do the same thing with the 2 out there. What's the heaviest next things on here? The 2 H's, right? 1 at a time. I kept saying, do 1 at a time, right? Until the ties are broken. We're almost there. And you're saying this is a foreign language. I have no idea what the heck he's saying, right?
Yeah.
Most of you should be saying that right now. This is a new language. I have no idea what he's talking about.
Yeah.
It's okay. I keep saying it over and over again. It's gonna sink in. And there's another loser. So winner versus 2 losers tells us number 1, right? The winner is the same distance from the stereocenter as the 2 losers, and up until now, everything's been tied. So what did we do first? We saw 3 carbons attached to a stereocenter. That, by definition, is a tie, right? I didn't lose anybody there, right? Then you looked back at those 3 highlighted in pink carbons and asked this question. What is the heaviest thing attached to each one of those? I highlighted those in purple, and I put check marks because they had 3, I didn't put 3, I did 3 check marks because they were all carbon. Still tied. That's what the check mark means. Still tied. Go back to your pink highlighter. Compare the next heaviest thing that you haven't compared. In this case, we're down to hydrogens on the bottom 2 carbons, right? Yeah. I'm comparing that to a carbon, the winner, on the top carbon. No, you're not going one atom at a time. I broke my tie with my winner. I have decided the number 1 thing attached to the stereocenter is the group starting with that carbon. We have not finished on the bottom. We have the 2 losers that are still currently tied, right? We're not done down there. We will break that tie very soon. We're going to do the finishing comparison here and here because we didn't finish everything attached to the pink, correct? They're still tied. So now you've got to go, of all the purple highlighted on the bottom, because we're trying to break the tie in the bottom now, right? What's the heaviest thing attached to this purple? Another carbon. We're going to go to yellow highlighters now. What's heavier, C or H? You answered your own question. Okay. Yeah. So we're comparing the heaviest thing on this purple, which is a C, to the heaviest thing on this purple, which is a C or a C. Those are yellow. Tie. Agreed? Go back to purple. What's the next heaviest thing on the purple?
H for the one on the left.
H for the one on the left. H for this heaviest thing has another C. Yeah, there's 2 of these good. This one. So tie, yellow tie, it gets check marks. Yellow tie, check mark, yellow tie. They're tied, right? And now I'm comparing off the purple. I gotta get rid of this. And admittedly, I did not start with a simple example. I apologize. I'm assuming you watch videos, but I know some of you didn't. It's an awkward moment for you. And we got the purple highlighter. And we're comparing yellow off purple, right? Now I'm comparing, I already had a tie right here. The C with the C, tied, right? Yellow, you're only comparing yellows. Go back to purple. What's the next heaviest thing? Second yellow is a C. Here, you're out of C's. H is now being compared to C. Which one's the winner? The winner. This was this one down here, right?
What are we doing with that?
We'll get a 2 and a 3 now. The 2 is the carbon to the right, and the 3 is the carbon to the left. So all the pink things, we broke those ties and put numbers. But you had to keep going away from the stereocenter until you saw a difference, 1 atom at a time. If you want to do a quick example that was like no-brainer easy that we should have started with, let's just do one like this. A CH3 compared to an F compared to a BR. And why not? We're going to have at least 1 tie, right? If you had to do 1, 2, 3, 4 there, I hope everybody's got the 1 for the BR, 79.89 grams per mole, 19 grams per mole for fluorine. Carbon, tied. Which carbon has the heaviest thing attached? It's an easy one this time, isn't it? The top one has the winner being compared to one of the H's on the bottom one, which is a loser. I'm not going to draw the H's. The winner is a C. We went from pink to purple.
It's really hard to get all the colors.
I know. Especially if you're colorblind, man. Wow.
Especially we're starting with.
This thing beats, one of the H's had to be in purple off of here, and I don't want to mess with my drawing. Winner and just loser. H, loses. Can't even read that.
And put it on the purpose then?
Yeah. Yeah. Okay, so we had a 1, and we had a 2, and we had a 4 and a 3.
What, how is it carbon like heavier than fluorine? Yeah.
How is fluorine heavier than, oh, I don't know where the 4 came from. I said that was 2 earlier. Yeah, when I said 2, I clearly didn't write 2. Correct?
No, isn't fluorine heavier than bromine?
19 versus 79. And we have 4 was here. Yeah. Yeah, you don't even need the number, just see where it is. And there we go. So that would be a more straightforward example. And after all that hard work, the next step says to put the number 4 group on a dash. You're welcome. You're gonna have to watch videos by Wednesday. Something called the double switch method that helps you do that without having any spatial abilities. Like I do not have these spatial abilities either. I cannot rotate molecules in my mind. There's a certain field that some of you want to get into where that skill is almost mandatory.
Like what?
It's called dentistry. You have to spatially know what's going to happen when you rotate something and you're looking at a mirror. Or else you're cutting into gums instead of teeth, okay? I'm just saying, you don't need to have that ability in this course because I have tricks for you that I use to overcome my disability of not being able to rotate objects in my brain. So we have tricks for everything. But if you don't have a spatial brain like that, then dentistry might not be for you if you want to get in people's mouths. Yeah.
What's this called? Like
Stereocenters. We're doing R and S on stereocenters. And on our example, since the number 4 is on a dash, here's our stereocenter. If you want to redraw it from, oh, I didn't need that C there either. That is our stereocenter, and the numbers were 1 on the wedge. All that I care about are the numbers now. And if the number 4 group is on a dash, then you're allowed to connect 1, 2, and 3 in a circle. Only if the number 4 group's already on a dash, which it is. And you're welcome. Notice I ignore the 4. I connected 1, 2, 3. Is the correction of that circle clockwise or counterclockwise? Clockwise is a clock working as it's supposed to. It's a righteous clock, R. If it was counterclockwise, it would be an evil clock. Another word for evil is sinister. Sinistrous is the Latin word where they got the S from. It just means counterclockwise for that rotation. Clockwise for this rotation is R, righteous. Rectus, if you want the Latin. So yeah, that little R is worth 3/4 of a point every time. And if you're in a rush and don't have time, you guess. That could be a 3/4 of a point just for the guess.
So it would either be R or what else?
S. And we're going to have an S coming up maybe in our next example, maybe in the one after. That's a
You
lot.
have to recognize there's a carbon attached to.
4 different substituents, yeah. And we got this thing here. It's been bugging me for a while. All right, now there's a ring with 3 groups on it. But there's only one type of group, right? What's the type of group called in this ring? It's there, and it's there.
ISO?
No,
No.
that's a single carbon group right there attached to the ring. Methyl, methyl, methyl. There's three methyls. Where's carbon number 1 of the ring? This or this? Top or bottom? Top. Because if you go that direction, you get a group on 1, and then the next group is also on 1. If you'd started down here as number 1, your second group is until number 2. This is the only correct numbering system for the ring. This has nothing to do with stereocenters. This is just numbering the chain in the correct direction. In this case, the chain is a ring. So your name is going to say 1, 1, 2. And what's after that? Careful. You haven't named your group yet.
Diamond.
No, there's 3 of them.
Oh, sorry.
Trimethyl. Now you name your chain, which is a ring. What's the name of the ring? Cyclohexane. And it's a 2-point question, and you got 1.25 out of 2. Congratulations. And you say, wait, you said stereocenters are worth 3/4 of a point. How come this question's not worth like more than 2 points? Well, there's only one stereocenter, that's the thing. Did some of you think there might be 2 stereocenters here? It's okay.
No.
The top one is not a stereocenter because you need to have 4 different substituents. Yeah, and a methyl is not different than a methyl any day of the week. The methyls are identical to each other. But this thing has a hydrogen, a methyl, a carbon with 2 methyls in the ring, and then a carbon that has no methyls in the ring. So I just said 4 different things for this stereocenter. And I think you can tell me what the number 4 is. Yeah. And most of you can probably tell me the 3, the methyl. It's a C with the heaviest thing being an H, going away from the stereocenter, right? Both the other carbons have another carbon. In fact, one of them has 3 carbons, which answers the question, which one do you like for 2 or 3? We're choosing between this top carbon and the bottom carbon attached to the stereocenter. The top has nothing but carbon, right? This one, the first carbon ties one of those, and now you're resorting to H's, and H's lose the carbon. So I think you got more out of that very confusing intro than you thought you did. Sometimes if you start hard, you say, okay, he's telling us this is impossible to start with. Don't do that. And then break it down. So I'm hoping you still got something out of it. And then this one, you're going to put your 2 on a carbon that has nothing but carbon. Oh, sorry, that's the 1. Sorry. And the 2 is the carbon with 1 more carbon. And the 3 was a carbon with no more carbon. And a 4 was an H, which is lighter than carbon. And there's sad news. Because I said, if the number 4 group is on a dash, then you can connect 1, 2, 3, 4. It's not on a dash. It's on a wedge. I'm going to help you out. What have I done so far? I didn't help you at all. What did I do, though? Just tell me what I did. What did I just draw down there? I drew the stereocenter carbon with only its bond. And I'm going to teach you how to do a double switch. And it's easy. You got them, all you need is these numbers. What you're going to do is find the number 4 and put it on the dash and switch it with whatever was on the dash. So the number 4 is here. It needs to be there. So I'm switching the 4 with the 3. That is called a single switch. A single switch changes the stereocenter to the other one. If I did nothing else and left the 2 and 3 the same, or the 1 and the 2 the same, sorry, then I would have done a single switch and I'll get the wrong answer. But if you do a second switch, I move the 2 up top and the 1 on the bottom, switches. The reason you did 4 with 3 was to get the 4 on a dash. That was the motivation, right? And do the other 2 because when you did the 4 with 3, you went from the right answer to the wrong answer. And guess what happens when you do the second switch? The wrong answer becomes the right answer, because no matter what happens, a switch gives you the other stereocenter. And there's only 2 types of stereocenters. What are they again? Give me the letters. S and R, that's it. So all you need to learn is a single switch is a trick. It's not chemistry. It's a trick to help you with this nomenclature. And it switches whatever was on the dash with whatever's where the 4 was. And the goal was to get the number 4 on the dash. That's the reason you did this, the first switch. And the second switch is you just screwed up the answer, unscrew it. So you're fixing it. Okay? So I guarantee you, without redrawing the whole molecule with these groups now where they are now, they're going to end up like this, the double switch. And is that clockwise or counterclockwise? And it looks like I'm preoccupied with clockwise. That was just coincidence. It's R. And please note that if you connected 1, 2, and 3 in the original, you did not get clockwise.
You would have gotten counterclockwise.
You did. And I kind of knew that was going to be the story for one reason. The 4 on a wedge it's exactly opposite of where you need it, right? Sticking. I'm right here. I gotta be on the video though. I'm right here. The 4 for you is sticking at you, right? It's on a wedge. You see it? Well, from my perspective back here, guess where the 4 is?
It's
Behind.
it's behind.
Yeah. So what I'm going to do, I don't even know. I'm going to undo this thing. This is going to look goofy on a very small screen. Okay, I'm going to go back there. So the 4 is going to be a dash for me if I'm back here, right? You agree? The 4 is out there, right? Okay. That's a dash for me, it's a wedge for you. I'm going to connect 1, 2, and 3 from back here. And you're going to be looking at something that looks like the wrong answer, but I'm going to prove to you it's the right answer, right? I got to be able to see the numbers here. Oh, okay. I got the 1, I got the 2, and the 3. There. I'm going to connect 1, 2, 3. I'm going to keep doing it. What's that look like to you? Looks like that to you. I haven't changed. What's it look like to you now? Because that's what it looked like to me all along. That's the correct answer. Do you want to be doing that?
No.
That was not. I don't want to see anybody dancing like this. on
Rotating
the
the molecule to rotate the direction while it's spinning, is that sort of how?
No, that's not about the spin. Here's the deal. There's several tricks in this class. The double switch is a great trick. It works every time. This trick can save you from the double switch. If the number 4 is on, if the number 4 is on a wedge instead of a dash, feel free to connect 1, 2, and 3 with this in mind. That is the wrong answer. You are 180 degrees from where you need to be standing when the 4 is on a wedge, correct? Think about it. Where's the number 4 need to be before you connect things? On a dash. What's the opposite of a dash? A wedge. If you connect 1, 2, and 3 when the 4 is on a wedge, it's wrong. When you have 2 answers and you know the wrong one, guess what else you know? The right one. So connect 1, 2, and 3 in the original, keeping in mind the 4 is on a wedge. S is wrong, therefore R is right. We've covered half the scenarios, you know? Well, I covered all 4 scenarios. There's only 4 scenarios. 1, the number 4 is already on a dash. That was the you're welcome in the first example, which wasn't a very good you're welcome because I started with a really hard example. Okay. There's the example where 4 is on a wedge. What do you do then? You connect 1, 2, 3, but switch your answer. And what was the trick you have to do if it's not a wedge or a dash? We did that already. We did it here. It's a trick that always works. It's called the double switch. We did the process. Get the 4 onto the dash. That was the first switch. That is the motivation of the first switch, is to get the 4 on a dash. That's all you're doing for the first switch. Second switch, just, you gotta do the second switch to get the right answer. Switch the ones you didn't switch already. You don't even have to do it that way. You can do any other switch, as long as your 4 is still on the dash. I could have switched 1 with 3. Then we still got the right answer. 2 switches gives you the right answer. Wow. I think that's the end of this video, and we'll come back for the other 2. This is our second 2 for the day, right?